All right, it should be live. All right, well, hi everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is your virtual star party for Sunday, July 28th, 2013. In the middle of the summer, the long nights, the late start for the folks on the East Coast. I deeply apologize. Don't worry. When we move around to the wintertime, we'll be starting at 5 o'clock our time, 8 o'clock your time. It'll be perfect. Prime time. While the rest of us won't even have eaten dinner yet. So it'll be good. So joining me tonight, we've got two astronomers, maybe a third, and we've got some other people along for color commentary. So joining me from Los Angeles, we've got Gary Ganella. Hey, Gary.
Oh, everybody.
And you got nice clear skies, Gary?
Yep, looking good.
Good. All right. And we've got Louis Mamekos from Central Pennsylvania. So he's over on the East Coast. So this is great. We're splitting the difference. We've got Gary on the West Coast. We've got Louis on the East Coast, and your skies are looking nice and clear as well.
Yeah, good evening, Fraser. They sure are for a change.
Good. Yeah, it's been
many weeks.
Yeah, that's gotta be rough for you.
Mm-hmm.
And for color commentary is Stuart Foreman. And
Hi.
And Stuart, last week we were sort of set to go, and then Stuart was the only one who actually had clear skies last week, and so unfortunately this week the fog rolled in, and he's totally out of luck.
Not so clear.
And Dr. Thad Szabo is trying to join us. He's having some problems with his internet connection, but we might get a view from his telescope as well. So we'll see if that all works. So just two telescopes tonight, but both astronomers have been instructed to go as quickly as humanly possible. And so hopefully, I think we're going to get through a ton of objects. We're just going to be efficient. This is going to be like a strike team. We're not messing around. There's not going to be any of this blah, blah, blah color commentary. We're just going to bang, just, hammer out all these objects. But before we as a treat at the very beginning, Louis, you brought us something really special tonight.
I did. Well, I guess it's special. I have Pluto, which used to be a planet before being disrespected than just a planetoid or asteroid or some other kind of object. This is a 60-second long image. Pluto isn't very interesting to look at in a small telescope like mine. You can't resolve a disk or anything, but here it is, indicated by the two red marks on the display. Let me sort of zoom in the star field. Believe it or not, that's Pluto. You're just going to have to take my word for it.
Well, if you took another picture, it would have moved a tiny little bit, right?
Yeah, that's right. If we were to come back, probably in a couple of days, you should be able to see that move to a different spot.
So, Louis, how do you know that's Pluto?
I went to my handy-dandy planetarium program and asked it where Pluto should be tonight, and the coordinates that it came up with actually match where it appeared in my image, so it must be Pluto.
In that you could see all those other stars in the field where the astronomy software was telling you.
Yeah, that's right, and my astronomy software has this capability to plate solve the image, meaning that I can take an image and it can match the stars up with the database that it has, and so I can sort of calibrate the coordinates of the image, and I can drive my cursor across the image, and it will tell me exactly what celestial coordinates are right under my cursor, and when I moved my cursor to where Pluto was, sure enough, it appeared right there.
Well, what constellation is Pluto in right now, if people want to go outside and look up and try and find it?
It's in Sagittarius. I'm looking at it right now, and it's actually right. And the reason why there's so many stars around it, it's right on the Milky Way disk. So it's if you look towards Sagittarius, right towards the Milky Way disk, you'll be looking right at Pluto, even though you won't be knowing you'll be looking right at Pluto.
Yeah, I pulled back in the image, and yeah, it's embedded in a pretty dense star field.
Yeah,
which made it a little bit of a challenge tracking it down, but.
Yeah, I think people, your telescope is quite a sort of narrow field of view, and so you're not looking at a very big chunk of the sky here. But I guess because we're looking into Sagittarius, this is towards the core of the galaxy. You're going to see a lot. It's a lot denser in terms of stars, just because we're looking towards the center of the galaxy as opposed to, up or down or out away from the galaxy.
Yeah, and this is an area. This is less than a square degree, so I guess that's bigger than a full moon, but still a relatively small part of the sky.
Yeah, you could just fit, the full moon with a little room to spare on the top, bottom, left, right.
Mhm.
Yeah, that's really cool. Well, that's great. That's our first Pluto viewing of the season, and I know Mike Phillips is going to be really frustrated because it's typically his job to bring us Pluto and Uranus and Neptune each. He did it last year, and we must have spent the whole virtual star party like, are we sure? Is that it? Is that it? Are we sure? And this, you're just like, yeah, there it is. There's Pluto. Let's move on. Okay, all right. That's this is how far we've come in a year. So, perfect.
Ho hum.
Ho hum. There's Pluto. By the way, there's Pluto. Yeah,
Yeah.
live for you in a Google Plus Hangout on air.
Everybody step outside and wave to Pluto.
the Pluto's not. New Horizons isn't taking a picture this week. So, all right. Well, I'm going to move back over to Gary's view.
This is the Trifid Nebula.
Right on.
And in color, it's nice because since I'm shooting in hydrogen alpha, I get all this hydrogen red area here. There's also a lot of blue, which is going to be some oxygen glowing, which I can't see. But I did take this at no binning, so it's 1:1. So here's some of the zooming in. You can see the dark dust lanes and all the neat little fiddly bits going on in there.
Little fiddly bits.
Yeah.
So this is the Trifid Nebula, aka M20, and this is a star-forming region in Sagittarius. So
M21.
it's M20.
This is M20. Yes.
Okay, then I got it wrong.
Only off by one.
Only off by one, but this is in Sagittarius. So this is this part. This is, we're looking towards the core of the galaxy, and the place is crazy with nebula and clusters and things like that, because it's just a big.
And it's not too far away from Pluto right now, actually. And
like the Trifid is really close to Pluto. Yeah.
It is, right. And it's about the size of a full moon. So you can actually take your binoculars, and if you know where you're looking, you can probably see a small fuzz where the Trifid is. And there's Thad.
Green Dr. Thad Szabo.
Good evening.
Where are you? Are you outside?
I'm in my backyard. So I have telescopes set up here, but still haven't worked out some of the camera issues and whatnot yet. So
you're not quite ready to go live.
Yeah. Are we okay? Well, we are on air right now.
We are on air. Yeah.
If you give me 15 minutes here.
I don't know whether we want your brain or whether we want your telescope at this point. I'd like both. You could just seamlessly go back and forth, sharing your knowledge and and the view from your telescope. Can we? But you missed something. So can we just go back, Lewis? Can you bring up the previous picture, because Thad just missed it. I thought he'd like to see it.
Sure. Give me just a second.
All right.
Sure.
We'll just go back for 1 second. It's a tiny icy object in Sagittarius. So if people want, you can always give us any questions, comment, feedback. If you want to make some requests, we're glad to take any requests. If you know your night sky, you know what objects you'd like to see. So if you can do that either on Google Plus if you're watching this on the event page, if you're watching this on my stream, or if you're watching this on YouTube, you can make a comment there. YouTube's sort of the safest place. So somebody's got an open. I'm getting some echo from somebody. Stuart, maybe. So anyway,
I'm muted. So
okay. So Thad, do you know what this is?
We got Pluto.
You got Pluto, yeah.
Yes, we have
very
Pluto.
Nice.
Yeah. So there's
very nice.
There's our first Pluto of the season.
So yeah, I mean it's well placed right now, especially because Lewis is on the East Coast, right? So
that's right.
It's going to be just past its highest point in the sky right about now for you over there. So, and although from PA, right, you're in Pennsylvania.
Yeah,
so
that's right.
It never gets that high off the horizon from there, though, because I grew up in Pennsylvania, and I remember not being able to see Halley's Comet because it was right over Allentown when I was growing up. So
yeah, we don't get much of a view of Sagittarius from here. It pokes up above the tree line and then heads back down. We don't get much of it. You got to be in the height of summer to be able to make it out.
Mhm.
Yep. But wow, good capture.
Yeah, it's
Thanks.
amazing. All right, well, and then I'll go back to Gary's view now, and then we can come back to yours in a second. So, Gary.
This is our perennial favorite, M16 Eagle. And I also did this with no binning, so we can zoom in and see all the pillars of creation and all that fun stuff going on in there.
And so can you embiggen it?
I can embiggen it a little bit more.
There we go. And there's the pillars right there.
Yeah, real nice. How long of an exposure was this?
1 minute at no binning.
1 minute, no bidding. So
I got pretty clear skies.
yeah, same here. So seeing as we're only about what 60 miles apart maybe. So
If that, yeah, something like that.
So, but one thing was, I was thinking, well, maybe I could bring Saturn, and then I realized it's right in the flight path of Long Beach Airport from where I am. And so we'd be able to see Saturn, and yep, plane just went right over it right now. So that probably wouldn't have been, be able to read the call number off the airplane or something. But yeah, I don't know about trying to bring Saturn from here.
So, oh, that would be great though. It'd be great if we could get it. We one time, didn't we? It was Mark or Corey had an airplane fly right through their shot of the moon. So we've had that happen before.
That would be happening on a regular basis from where Saturn is and from where my scope is set up right now.
Well, now I want to see this.
Yeah, give me 10 minutes.
Yeah, I can. I've got my cheat sheet here, so I can do I can play Thad for 15 minutes while you're
keep messing with it.
Yeah.
So Jose Barrero asks for NGC 7008. Anybody know where that is?
So 7000 is the North America Nebula. So 7008. Is that the Pelican? I don't know. I'd imagine it's kind of up.
The Fetus Nebula. The Fetus Nebula?
Oh, Fetus.
Fetus?
Phaetus.
It's Fetus.
Fet.
Yeah.
So Fetus Nebula. Okay. No, I haven't heard of that one. So.
No.
There's no way that Gary's going to be able to get it. Lewis might be. It's only 1.6 by 1.2 arc minutes.
Yeah, it's really tiny.
Yeah, it's the constellation Cygnus.
Yeah, it's a planetary nebula.
Yeah.
Yeah, that's probably not going to show up really good at my image scale, and the seeing is not really that great here tonight either. I have NGC 7331 from about 20 minutes ago.
All right, let's talk about this then.
Yeah,
right.
Yeah.
This is the Cocoon Nebula. Oh no, you had the Cocoon Nebula up. Can we take a quick look at that?
Oh yeah. Let me put that back.
Shame to waste a nice image that you had there.
There we go, the Cocoon Nebula. This is a 1 minute exposure as well. It's a little noisy. I've done some other work with this object in breathtaking full color, including hydrogen alpha, and it's a beautiful object. What I find interesting about this object, it's also embedded in the Milky Way, so it's in a very dense star field. It's an emission nebula, meaning that this part, if it was color, would be glowing in a hydrogen alpha reddish color.
Right.
So emission nebula here, and off to the side, I'm not sure, yeah, my cursor's showing up. Off to the side here is a reflection nebula, so it kind of glows blue, illuminated by a nearby star. And then the other neat thing is you can see sort of diagonally across the image, it's not that there are fewer stars here, it's just that they're obscured by dust and gas, which I presume is associated with the nebula as well.
Yeah, so it's another one of these complexes where you have dark nebula, emission nebula from hydrogen gas, and reflection nebula. So the Trifid is similar to that, although not quite as much dark nebula, way more emission, and then that beautiful kind of blue reflection nebula that the whole thing is immersed in. But this is one that's much better placed for people at higher latitudes. This passes very near the zenith for people at higher latitudes. And if I remember correctly, Corey Schmitz is trying to do a large-scale kind of mosaic of not just the cocoon, but a large portion of the sky surrounding it as well. So
he's just the man for the job.
that could be something we have to look forward to by the end of the summer here. No pressure, Corey.
No pressure, Corey. Yeah, that'll be great.
So,
But yeah, it really does look like almost like a comet, like a dark comet, like it's got a dark tail behind it.
so yeah, again, it being in the thick of the Milky Way like that, you can definitely have the it provides contrast for where the dark nebula is. I mean, you can have a dark nebula in another region of the sky, and you'd really never know it's there because there's no stars behind it that would be coming through. And I'm hearing echo on myself too. So.
Yeah. I'm gonna try muting Gary first. So, are we still getting echo?
I don't know. Am I?
I think it's Gary. Yeah, I think we killed the echo. Sorry, Gary. Oh,
Well,
wait.
No, that's me. I just unmuted myself. This is an experiment. I don't know why I'm echoing. So
The sound's probably just coming from your. If you can turn down the audio on your headphones, it's coming from your headphones and back out your microphone.
Okay, I'll mute that down.
Yeah. Okay. All right. So Jose says you can definitely bring in the NGC 7008. It's bright. He's begging you, Lewis. Begging you.
All right, I'll see what I can do. That was 7008.
Yeah, and we've never seen it, so
if anybody can do it, you can. You've got the scope for it.
Yeah.
Yeah. Okay.
I think that'll be great. And Terry Rhodes confirms that the stellarium showed Pluto just like the picture. So, you know, the position of all the stars that we had there was Pluto.
I mean, just to give you its idea of image scale, what the what the person is asking for is about 1/5 the size of the Ring Nebula. I mean, it is tiny.
That doesn't sound too hopeful. Last night I might have been able to shoot something like that. I was shooting at f10 last night, and I've got a shot of...
I have a Ring Nebula I can put up. I took.
It's not alive.
Yeah, we're losing you, Thad.
Oh, sorry. So yeah, this was a shot of M13 that I got last night, and I was shooting at f10 at that focal length. Then I might have a shot at something along those lines. But let me just bring up this image. It's kind of breaking the rules, but hey, it's fresh from last night. Is that?
It's fine. It's fine. I've relaxed the rules now. I'm not so hard about it anymore.
So this was this is from my backyard, which is in Long Beach, and this is a whited out area. I mean, right now I have the glow of the computer monitor on me, which is making it kind of even more difficult to see some stuff. But even if I didn't have any lights back here, I wouldn't even be able to see the keystone in Hercules, which is where this is located. But let me just share this out here. Hey, we got NGC 7331 there. Okay, but
well, I'm gonna move to Gary's view here. Oh, here we go. Okay, great. Let's look at your photo of that.
That was my shot of M13 from last night, and this is a highly light polluted area.
Wow.
So just
how much total image capture was that?
Let's see. So it was 34 20-second exposures. So 34 individual 20-second exposures at f10. And see, it gets a little noisy around the edges. But this was with stacked in nebulosity and processed in Pix Insight. And
came out real nice.
Yeah.
Thanks. Yeah, this it was kind of lucky imaging, just playing around, like, what can I do for my backyard? Do I still have to drive 2 hours to be able to shoot deep sky objects? And
depends on the object.
Depends on the object. Something very bright like this, I can do from here. If something like the North American Nebula, no way. Right? There's no way I'd ever get that from here. I shouldn't say no way. I should try. Maybe should try some stuff with filters first. But this was non-filtered.
Mm-hmm.
No light pollution filter. No other filters applied.
What was your camera?
An ATIC 314L Plus color CCD camera. So it does RGB just in one shot.
That would be nice live, even. That'd be great. I'd like to see that bad boy in the Star Party.
Like I said, if you can give me Stuart, if you can cover me for 10 minutes, I can.
I got your back.
Yeah, we got your back. We can do it.
I can do it.
I can serviceably also talk about space stuff.
All right, let me leave that up here in the meantime then, while I go work on this.
Sure. We'll just keep going back to it and and gazing at it.
Okay.
Someone wants to know what size telescope Thad has. He's got a 9.5-inch telescope, if I recall correctly. Someone's asking for NGC 6823. So anyway, Gary, what is this?
This is the Swan,
Nice.
M17. And again, that one's taken at full res, so I can zoom in and see all the neat little things going on in here.
Yeah, I love all these sort of little complexes, these lanes of dust and gas, and then also you can really see that bright area there, where there's a bunch of really young hot stars that are putting out so much radiation, they're just blowing out the exposure. We get that same problem with the Orion Nebula too.
This nebula has a bunch of different names. The Omega, the Swan, the Horseshoe, Lobster, M17, and this is a very bright nebula in the southern skies. It's a lot of fun to image, and it's really nice in color too. It's nice and bright red emission nebula.
So can you zoom out again, Gary? I want to see if we can see the Lobster, because I think we've seen that.
Yeah, I don't remember how we saw it now.
Yeah, I don't remember either.
Maybe just the body and feet and stuff and the tail here.
You got to remember that as well, that you could always be flipped, right? But I'm seeing like antenna on the top there. I don't know.
Yeah, I don't think.
I don't know. I always love. Oh, you flipped it. Okay, all right.
Yeah. I'm not seeing anything any better flipping it though.
No.
But it's a fun one.
That's funny. Cool. Okay, great. I'm gonna go back to Lewis' view now. Lewis, NGC 7331.
Yes. And not quite an edge-on spiral galaxy, but there it is, and there's a complex of them, or a cluster of galaxies. There's one here, which is a little more difficult to see, and I think there's one here and one here.
I think I see one on the upper right as well.
Oh, up over here, yes.
Yeah.
This is also a 1 minute exposure.
That's great. 1 minute. Wow.
What amazes me about this is that you just look at this in this tiny little field of view, and you see just a bunch of galaxies. And these are galaxies with what, trillions of stars or whatever.
Hundreds of billions.
Hundreds of billions of stars.
Yeah.
And each one is its own separate galaxy, and you're just in a single glance you can just see trillions of stars.
Well, what's really great about this one specifically is it's very similar in size and structure to the Milky Way. So they sometimes call it the Milky Way's twin. This specific galaxy.
7331. Let's see. Yeah, I'm not sure.
Caldwell 30.
Right. I mean, I'm not sure if it is a barred spiral or just a regular spiral. And I mean, if it looks like it does have somewhat of a bar shape, but it's not quite as distinct. The Milky Ways would be way more distinct than this one viewed from afar. But again, I mean, it is a good-sized object. It's surprising that Messier missed it. Of course, if he had skies like I have right now, he would have missed it, because in the time between when I was looking to see how well aligned I was and all, and now we've got clouds rolling in off the Pacific. So sorry, I can't really bring a view of my own. But but let's see. Yeah, but NGC 7331, part of this group, and like Stuart was referring to, you can see some of these other galaxies, these other little fuzzy patches off to the left of the image that Lewis has here. It's called a deer lick group. I'm not sure why it's a deer lick, but...
So my software, Thad, says it's an SB galaxy. What's that mean?
So SB is so spirals have... it used to be this kind of tuning fork classification that can't remember if Hubble came up with it or not, but the idea that you have ellipticals that look spherical, and that's called an E0, out to ellipticals that are fairly elongated, which is an E7, and then you have spirals that are tightly wound, which was an SA or an SB or an SC, and then the most loosely wound was an SD. But then you also have barred spiral galaxies like an SBA, an SBB, SBC, SBD. So SB means it's a spiral galaxy and fairly tightly wound.
Yeah, let's move on. So Gary's view.
Yeah, I've got another one coming just now.
Is the upside down Borg galaxy here? The Borg.
This is the lagoon,
Yeah.
but I'll show you something interesting in it. I'm starting to lose my focus with temperature change. See, the stars look like little crescents.
Right.
So I just took a second one and let me load it up. I ran a quick autofocus in between, and come on, give me it. Hang on, it'll.
But I think it's upside down from the view you normally give us. Oh, that's a lot crisper.
You know what it is? Yeah,
Yeah.
the scope did a flip.
I hate when that happens.
I know. It's a pain. Come on.
Well, it actually shows you pretty orthogonal if you could do a flip and still get it.
Oh, it tracked really nice. Let me, yeah, there we go. Didn't even stretch that guy.
Yeah, it's a lot crisper. So can you flip it? Can you flip it upside down? I know I'm asking for so much. You're trying to embiggen it, and I'm asking you to flip it. There it is.
Is that more gooder?
Now we see that. Yeah, now we see the Borg Homer that we always see in this.
Oh yeah. The little wisp
Borg Homer.
hair.
I just got that. That's hilarious.
We will be assimilated.
Don't.
It's getting awfully silly in here.
Yeah, really? Oh, we're just getting started. If Scott was here, it would just be madness.
So what were some of the details that you were hoping to point out with this, Gary? That I mean, it looks like we've got some of these dark globules that are showing up pretty well in contrast with this exposure. Was that?
Yeah, this has got some really nice ridges. Right there. There's this one.
Yeah, look at those like little trails inside. Just amazing.
And then you've got the dark areas that this has got to be star forming.
Yeah, exactly. Those knots where you see, this bright background, and then this dark. Yeah, there's a real good one close to center there. That just looks like this little trail coming off of it. When you see this in an emission nebula, you're looking at a region that is forming stars, especially just a little bit right of center in that view. It's like this little knot with this little kind of stream coming off of it. This is kind of classic. It's like the pillars of creation. Except this is what's going on for the Lagoon Nebula, and somewhere deep in that darkest part of that is a star being born. So,
and you can even see Homer's nose hairs here.
Are there any donut crumbs on those, or?
Yeah, I think that it's hanging here in the mustache.
Okay, so we've got Lewis has got another planetary nebula for us, and this is a classic. M57 Ring Nebula.
M57, the Ring Nebula. My seeing was starting to go bad. It's not very crisp, but you can still resolve the central star, which presumably is the star that blew off the shell of gas that we see as a ring.
Well, I think Thad is going to debunk that now for you.
Oh no!
Yeah, I mean it's kind of this unfortunate alignment that goes on with the Ring Nebula. The central star is actually a 15th magnitude star, so very, very faint. Yeah, so it's really that's not it. That's just kind of a chance alignment of another star that happens to be in about the right place to make people think it's the central star, that the white dwarf that formed the Ring Nebula. I mean, the Dumbbell Nebula is the white dwarf that got that one, that's keeping the energy going for that one, is is pretty distinct, but for the ring, it's actually a good bit fainter. So.
Well, I have a dumbbell I can put up if we want to look at that.
Sure. I think Nick Rose is going to have a seizure if we don't get some of these objects up. So we've got he's asked for NGC the 6823. Did you try that one, Lewis?
No, I've got 7008, or at least the field, but I don't see anything.
I don't see anything in there. Yeah. So that's right. So he asked for. Oh, sorry. Jose asked for 7008. Yeah, I got a ton of requests actually from Nick here, so I'd love to see if we can take a crack at some of these. So we got NGC 6823, an NGC 7380, and NGC 6643, and NGC 7013. So I don't know if any of those are up.
6823 is. I'm looking at it right now.
Oh, really? Okay.
That.
I'll put some of these into the chat, and you guys can kind of.
It looks like a globular.
Yes.
I was just trying one that we hadn't done before called the Cloud Nebula, but I'm not getting anything out of it.
Yeah, 7380 is just a faint open asterism almost. It's just a cluster. What else do you want? 7008?
We got Cassiopeia A 3C461. Is that like
Cassiopeia A? I'm not sure how much you would actually see with that. I mean, it's the remnants of a supernova. It looks way better in X-ray.
Yeah, I'll bet.
Yeah.
Now this is fun. So somebody asked to see the center of the Milky Way. That should be possible, right? It's in Sagittarius.
With you really need a DSLR and set to a pretty wide field and a good dark sky to shoot it from. I mean, with a telescope, you're really not going to get.
But can't you get the star? Like, couldn't we image the supermassive black hole?
You'd be able to image the stars that are nearby. The problem is there's so much gas and dust between us and the center of the Milky Way that the only way to penetrate all of that to be able to see anything near the supermassive black hole is using an infrared telescope. So what you could see is the gas and dust and the more nearby stars that block our view of the center of the Milky Way.
Yeah.
But actually, yeah. I mean, sure, we can point.
Yeah, that's what I'm saying. So, I mean, obviously, you're not going to see this amazing supermassive black hole with stars whirling around it, and you're going to see a place with stars, and you have to use your imagination for the rest of it.
And dense. I mean, yeah, it will be fairly dense with stars because you would be looking through the thickest part of the Milky Way.
Yeah.
But yeah, unless Gary or Lewis here suddenly got a telescope that's up at about 7 or 8 kilometers or higher and can do infrared. You're not going to be able to see through all that gas and dust.
I don't have my tower installed that I can climb yet. It's only
but this
about
is
4
great.
kilometers.
I mean, I'm loving all these requests, and the people who are out making the requests know their sky, so it's kind of cool. We've got some great stuff.
I'm not seeing Orion Nebula, which is
no, I know this is great. Yeah.
Gary, I put the center of the Milky Way, the coordinates, into the chat. You can put it in if you want to.
Okay, I'll do that. Let me.
If you can just show the middle of it.
I'm trying to do 6823 right now.
Okay.
Monk Ellipse just was wondering why we don't have color. And so
because I'm clouded out.
Yeah, because Stuart is clouded out. So there's kind of two kinds of and I think Thad would have brought color as well. So there's two kinds of cameras that the astronomers like to use. One is the black and white ones, and actually both Gary and Lewis are using roughly the same camera. You're both using this QSI camera, and it's really, really sensitive and really high quality, but it's designed for black and white. And so when they're doing sort of deep sky imaging, what they'll do is they'll go back and they'll take like one image for a long period of time in one color, and then they'll switch their filter, and then they'll do another image for a long time in another color, and then they'll switch their filter, and then they'll build up this 3-color view of the sky that then looks like color. While what Thad and Stuart can do is they just have a color CCD camera that they have connected to their telescope, and it takes a full color image. So the downside is that it's not as sensitive as what Lewis and Gary can get. So sometimes, some nights we have a whole bunch of color cameras, and some nights we have black and white ones, and so with these black and white ones, we just get these these subtle details that we just don't see with the color cameras. So, you kind of got to appreciate them both.
Well, it also has to do with where you are. I'm in a very light polluted area. So when I try to take pictures with a single shot color, I just don't get much out of it at all. It's just too much sky glow.
BTL 743. Yes, we can see your comments. Yes. Okay, so Lewis has put something new up. What is it?
This is the Dumbbell Nebula.
The dumbbell, yes.
So this is Messier's 27th object. It's also the remains of a star a bit more massive than the Sun, but not immensely more massive. And when it died, it kind of puffed out its outer layers like this. Yeah, just like that too. But here you can actually see the star in the center is the white dwarf.
Oh, it is.
Yeah, for the dumbbell, you can see the central white dwarf star for this one. So, I mean, the thing is, white dwarfs, it's the leftover core of a star like the Sun after it's died. There's no more fusion going on. It's not producing any new energy. But because the center of a star is so dense and so extremely hot that this leftover core of it will glow for about 1 billion or more years, long after the star is gone. And so it provides enough ultraviolet light to kind of jazz up the electrons and the gas around it. And so we see the effect what we get is the Dumbbell Nebula.
That's great. I've got one question for you, Thad, from Sterling Gothrop. How many arms of the Milky Way are between us and the center of the galaxy?
So is this like how many licks does it take to get to the center of a
galaxy?
Yeah.
Massive black hole.
1 billion. Anyway, so let me see. There's the let's see. We're in the Orion Spur. Between us and the center. So let's see. There's the Centaurus arm.
I'm gonna find an image.
Let's see. Yeah. I'm thinking. The Milky Way is a kind of classic two-armed galaxy, but with some extra kind of spurs and extra little things kind of coming off. So it's essentially, I mean, it should just be, if I remember correctly, that it is really it's one arm. But I mean, the arms in the Milky Way are complex. They don't have. It's not just like one neat arc. It's all these little kind of prongs and whatever else kind of coming off of it.
Okay, here you go. So I've just put up an image of the Milky Way, an artist's representation of the Milky Way.
Right. So let's see. So is there a UR here in this?
Well, I think we are kind of right about here, I think.
Yeah. So I mean, essentially, actually, I think we're out a little bit further than that, but still, it's essentially one arm, and then you're kind of getting into where the central region is. So.
Yeah, so we've got this arm and then the central region.
Yep. Yeah. But again, we're in a spur, so we're not exactly in a thick arm of the Milky Way here. If we were, there would be way more stars visible at night, but we also wouldn't be able to see as deeply into space, even without interference from with the interference from the gas and dust in the Milky Way. That about the farthest you can see from our position in the galaxy is about 3,000 to 4,000 light years out. If we were in a denser part where there was way more gas and dust inside one of those tightly wound inside one of those denser parts of the arms, maybe we'd only be able to see about 1,000 light years out or so. So
Wow.
Where we are, we get a little bit better view because we're not in the real thick of one of those arms.
Awesome. All right, so we've got a bunch more objects here, so let's keep rolling. So Gary.
This is the requested 6823. Now I had to bin that. That's a 1 minute, and it's binned at 4x4, so I can't enlarge it. It's pretty dim here. This is something I would take long exposures of if I was going to.
But it's got a great, really great kind of dark dust lane there.
Yeah, it's one that I'm going to have to go back and look at. I made a note by it.
I've decided this is the Loch Ness Nebula.
It's Nessie.
Yeah.
So you have again kind of classic arrangement. We have a star cluster at the center of this. You have the emission nebula, the leftover hydrogen, some of which went into forming those stars in the cluster. You've got this dark nebula impinging here. Again, new star formation going on where you have the dark nebula. And then you even have this bit of embedding around it. I mean, if you're looking kind of above, like around the nebula itself, above and below it to the left, you can see it's kind of embedded in a dark nebula. So I
Here,
mean,
I'm gonna screen share an image that came from Astronomy Picture of the Day, and so you can see that crazy dark dustling there.
Yes, and I had not imaged this one, so
well, this is
I
great.
have to go
Well,
back at it. That was
I love
wonderful.
it. So I think that was a great suggestion. Was it?
Which one is this again?
This was 6823. And who asked for 6823? You can suggest stuff for us anytime. Jose asked for it. So thanks. That was great. You know your sky.
Yeah,
A new object that we've never seen before.
Where in the sky is this? I'm not familiar with this myself.
Let me look it up here.
It is not
It's in Vulpecula.
We get a brand new object. Yeah.
So Vulpecula is also where the dumbbell is. So if we go back to Lewis's previous view there, that object and this object are kind of neighbors.
Neat.
Yeah, it's in Cygnus.
Yeah, it's not too far from Alberio.
Okay.
Mm-hmm.
Ronald Minch gives us a mini update on Comet Ison, that it's growing in magnitude slower than expected and may not reach magnitude 10 until September. I don't know if you've been tracking Ison, Thad.
A little bit. I mean, I saw the picture that Scott posted,
the Hubble one.
The Hubble one with the galaxies in the background.
Yeah, that was pretty great.
Yeah, growing slow. I mean, comets, they just be so kind of random with what the conditions are for each particular comet. So, growing slower, I think to me that would seem a little bit more encouraging. It's if they, start to evaporate quickly when they're far out, that can cause a bit of a problem. So maybe if it's, maybe if it's brightening a little slower, maybe it is a little more compact and has a better chance of making, surviving this trip around the sun, and giving us the show that we all have every set of fingers and toes and whatever else crossed in hopes that we get that view that weekend after Thanksgiving, which is that's the weekend, right? The American. So sorry, Fraser. Yeah, American Thanksgiving, right? That Saturday and Sunday. After that'll be the days for the view for Comet Ison. So.
Yeah, and I feel so bad because people are like, what's it going to do? And we, our answer is we have no idea, and we won't know until it happens or doesn't happen.
Yeah.
Like it's got to come from the backside of that sun, and the moment it does, we'll know whether we're in for a big show or whether it's fizzled out. So, and there's no way to know until after that happens.
So stay tuned.
So, Lewis, you got M13.
Yeah, I've got M13 up now, a globular cluster, and I can try to embiggen it. Whoops. There we go. This is also 1 minute exposure I managed to get off a little while ago.
Yeah, so I think, again, I mean, we were talking about the difference between the color and the black and white cameras. I mean, this is a 1 minute exposure, and Thad, you were taking minutes and minutes and minutes when you add up all those exposures that you're doing.
Yeah. I mean, each individual shot was only 20 seconds, though.
Yeah.
So, the main thing there with the averaging does is it gets rid of kind of noise. It gets rid of, it does help build up a signal, yes. But, it's kind of the square root of the number of exposures that you have as to how much taking multiple exposures helps to reduce noise.
Does it make more sense to take a bunch of short exposures or to do one long exposure?
It depends on the object. The thing is with 16-bit cameras that exist nowadays where you have about 65,000 different light levels possible, you can take short exposures and get about as much detail as you would with like an 8-bit camera. The thing is, though, if you want something that's really rich in different light levels, galaxies do much better with longer exposures. Getting the faint outer tendrils of a nebula, you really need that kind of long exposure, and then do processing so that first of all, clobber out the background, kind of bring up the light levels of the outer tendril part subtly, kind of flatten out the bright central area. There's processing to make these images look the way that we see them. But the general rule is the more light that you capture, the longer an exposure that you can have for a faint object, the more light, the more levels you have to play with. You also run into the opposite problem, though, with something very bright like M13, is if you go with too long of an exposure, now you've overexposed it, and you've filled up all of these buckets with as much light as possible, and now you don't have any room to play with anything because you just bleached everything out. So it's, kind of knowing your object, knowing your optics, knowing your camera, and then kind of setting exposures for the right kind of range, so you still have room to play. That's the main thing. Anytime you're taking photos, you want to leave yourself room to play.
It definitely is an art. Okay, I'm going to move to Gary's view.
This is the coordinates from Stewart for the center of our galaxy.
Right on.
So there's some nebulosity. This area's got all kinds of stuff going on, but somewhere right around in here is the center of our galaxy that's hidden by all that nasty dark dust.
Yep, so this is it's on the border between Scorpius and Sagittarius. If you look at Sagittarius as a teapot, there's the triangle that makes the spout, and you follow the top two stars in the teapot and kind of slide over a little bit to the west from there. That's right about where the center of the galaxy is. Now, Messier 7 and 6, which are some huge star clusters in Scorpius, are just south of the center of the galaxy. And again, I mean, you're looking in the thick of the galaxy, so you're going to find emission nebulae, you're going to find star clusters, but you're also going to find a lot of dust that, unless you have access to the Keck telescope or some of these telescopes in Chile, you're never going to penetrate that dust with visible light, and it will block the view of where that supermassive black hole is.
Right, but right now, all of us are staring right at a black hole with 100 million times the mass of the sun?
About 4 million. Yeah.
Oh, 4 million, right.
Yeah.
Sorry.
For our galaxy, it's only about 4 million. And it was Andrea Ghez at UCLA who had done the studies of tracking the motions of the stars near the center of the galaxy. Again, using infrared telescopes, using adaptive optics, really kind of pushing the limit of what our capabilities are at this time, and has been able to map this out. So if you look for galactic center group at UCLA, then you can see her work. You can even see some of these GIFs, some of these animations that she's created tracking the motion of these stars.
There's a terrific Nova episode where
she has done some great work.
Yeah, where they cover her research, and they show this wonderful animation of these stars whipping around the supermassive black hole, and you can really see the amount of gravity that's got to be there for them to make this journey. It's just astonishing.
Yeah, I mean, real hairpin turns, and these stars, they're more than the mass of the sun. So something that can just whip it around like that, like this game of Crack the Whip, that's got to be quite massive. And if you use essentially modified versions of Kepler's law, if you use Newton's extension of Kepler's law, there you can figure out, well, the thing that they're whipping around has got to be about 4 million times the mass of the sun. If you take my Physics 100 course, you have to do that as a problem, is figure out what the mass is of the supermassive black hole using some orbital data. So
I've got an actual image here. I'm going to try and share it. Okay, let me see if I can share this image.
There we go. So yeah, I mean, this is, if you look at the scale, right, at the top of that image that you're sharing, it shows 0.2 arc seconds. Right, so an arc minute is 1/60th of a degree, and I imagine Gary's field of view here is probably about what, 2 degrees across, maybe?
1.5 by 1.
Okay, all right, so 1.5, all right, so I was overestimating a little bit. Okay, so if you took his image top to bottom and you cut it into 60 equal pieces, each slice would be 1 arc minute. All right, then if you took one of those slices and chopped that up into 60 pieces, that would be arc seconds. So the field of view that we're looking at from this picture from the Galactic Center group, right, is about 3,000 times smaller than the size of Gary's image here from top to bottom.
So just zoom in, Gary.
Okay.
Yeah. Just zoom in.
Don't do any binning. Just
enhance and magnify.
Zoom into my square stars.
Yeah, so we'll go back to Gary's view here. That's awesome. Yeah, it's a great. I think it's called Galactic Monster or Monster at the center of the Milky Way or something like that. Anyway, look it up. Nova episode on the supermassive black hole. Oh, cool. Okay, so Lewis, you've got a treat for us. I'm going to go to your view of... oh, we lost it. Okay, that was M3. Whatever. We've seen a globular cluster. No, move on to your next thing.
Okay.
Because this is cool.
There we go, Neptune.
All right.
Nice. So we had Pluto, and now we have Neptune. Good night. This is great. The two of you just tag teaming.
It's too bad it's not color, because it would be purple or blue.
Yeah.
Yeah.
Deep blue green color. And I'm wondering if we're seeing Triton off to the one side. I mean, not below it and to the right. That's way too bright for Triton.
Oh, right there.
That little dot that's just at about 10 o'clock relative to Neptune. So, yeah, I wonder if we've got Neptune's largest moon there, too.
You know, I might have software that can tell me that.
I think someone's using Stellarium too, so maybe they can tell us whether that's Triton as well. But Uranus is still not quite up, right?
Yeah, Uranus is kind of on the border between. It's in Pisces right now. So, but Neptune is in Capricorn. No, Capricorn. So say we all. But Neptune is in Capricorn. I guess it's slowly eking its way over toward Aquarius. So for Lewis, it would be pretty well placed right about now.
So sadly, we're not seeing Triton. Triton would be right here. It may actually be stuck in the glow of Neptune.
Oh, okay.
This was pretty low in the sky and kind of muddy, so it's bloated. It may have bloated over where Triton is.
Okay. And again, you're working with a fairly large field of view, so it's fairly likely that it would be kind of blown out. So.
Yeah.
I'm going to move to Gary's view. Thanks, Lewis, for Neptune. That was awesome. Great.
Yeah.
Pluto, Neptune, what happens when you take a picture of Saturn? Is it just too bright?
It is pretty bright. I'm trying to think if I've really imaged Saturn with this scope. I mean, I don't think I have.
Oh, you know what? There's nothing I like to hear more than that.
Yeah, with this scope and camera combination, I imagine Saturn would look like an oval blob.
Yeah.
But you'd probably be able to get a fair number of the moons around it. I mean, Titan shows up very easily, but I know that I've there was one night I was shooting Saturn with the CCD camera that I typically use for deep sky stuff because I wanted to see how many moons I'd be able to pull out. I mean, Saturn is just overexposed oval in the middle, but yeah, I think I was able to pull out like 5 or maybe 6 moons from imaging it that way.
That's pretty great. Yeah.
I'll have to try that. It's not really a planetary scope, but I should be able to resolve the moons.
I don't want you to break your telescope.
Yeah, it'll be fine.
All right. Were you going to try tonight, or are you going to try another night?
Saturn's set for Lewis.
Is it set for him already?
Oh,
yeah. Yeah. All right. Let us know the result of the experiment. Well, I think we got time for one last image. So I'm going to show Gary's last image here. I don't know did you have something else queued up, Lewis?
I can put M3 back up, but
yeah. Well, we didn't get a chance to talk about that, so we'll take a look at that for a second. First, Gary, I see the propeller.
That's it. Either that or it's the cheesy Italian mustache.
It's Mario or Luigi. Yeah. So.
And we've decided that it's complete fluke that the nebula is in this shape.
Yeah, I mean, it depends on where we are relative to it. Depends on how it's evolved from the stars that have formed from it, how that's kind of pushed some of the hydrogen gas and dust away. So yeah, again, any nebula, any arrangement that we see is a fluke. Right? It's really just happens to be whatever the way things have shaped it to look that from that particular region of gas and dust, and our perspective of where we are relative to it in the galaxy here.
Well, we had that conversation about the ring nebula a couple of weeks ago. That the thought is that it's not just a ring, but it's actually like a cylinder that we're looking down the tube of it.
So yeah, that it is a little bit more. It's kind of more egg shaped, right? And we happen to be looking along, not looking at the egg this way, but looking at it more
down
like this.
Yeah.
So
and we're seeing an
not the egg on the side, looking down at the point of the egg.
Yeah, exactly. Yeah.
And if you want to go balance an egg even today, you can do it.
You can do it. You don't need to wait for the equinox. All right. Well, I'm gonna close up on Lewis's beautiful view of M3. So just another globular cluster. I know we had a couple of requests for that. Sorry we didn't get all those other objects, but I do appreciate the request. That was awesome to get such knowledgeable requests and a brand new object that we haven't seen before. That was wonderful. I'm really excited. I love when someone goes, "Hey, you guys should check this out," and then we do, and it looks great, and we'd never seen it before. It's my favorite thing ever.
Yeah, I just tried 7008 and I can't. It just looks like a star.
It does? Okay, yeah.
But
and Lewis said the exact same thing. He tried 708 and just nothing that was he could tell that wasn't a star. So. Cool. Okay. Well, thanks everybody for joining us tonight and watching the night sky. We actually made it through quite a lot of objects. That was really great. And thank you very much for Gary and Lewis and having your clear skies. That's perfect. And thanks Stuart for bringing the color commentary. And Thad, I'm sorry you didn't get your telescope streaming tonight, but I suspect we'll probably have you next week. But now you have a backyard. Right?
Yes. So now I can actually just set the thing up and kind of just put it under a tarp and leave it out here and come out the next night and be ready to go in about 15 minutes as opposed to 40 minutes is typical setup. So
right out in the front yard in the street, right, with people coming and checking
by and, hey,
yeah,
and it's like, okay, well, I'm trying to do outreach, and if I can do it in person or I can do it online, I can't really do both at the same time. So,
yeah. Well, don't lose your interest in sidewalk astronomy. So go out into the front yard every now and then.
So nicely enough, my father-in-law's father had bought a Quest Star back in the '60s. I am now custodian of it. It's not mine, but he's letting me keep it, and I've been using it for some outreach. That is a beautiful instrument. If you ever get a chance to look through a Quest Star, take it.
So Ronald Minch notes that Sky and Telescope has a good article by Alan French on eyepieces, and the latest Sky and Telescope has an article about the virtual star party in it, which is kind of cool, written by our good friend David Dickinson. So, if you can get your hands on the new Sky and Telescope, you can read all about the virtual star party. But you probably already know everything about it already. So. Cool. Okay, so tomorrow we may or may not be doing a astronomy cast. I'm not sure where on Earth Pamela is, so if that's going to happen or not. But if not, we will definitely be doing the weekly space hangout on Friday. I'll have 2 more explainer videos coming up this week, talking about panspermia, I think, and a stellar engine moving stars around the galaxy. So you can check those out on my YouTube channel. Just go to the Universe Today YouTube channel on YouTube, which you're watching right now. So, okay, great. Well, thanks everyone for watching us. Thanks everyone for joining us, and we will see you all next week.
Bye, everybody.
Good night, everybody.
Bye.
At no binning, so it's 1-to-1. So here's some of the zooming in. You can see the dark dust lanes and all the neat little fiddly bits going on in there.
Little fiddly bits.
Yeah.
So this is the Trifid Nebula, aka M20, and this is a star-forming region in Sagittarius.
M21.
M20.
This is M20. Yes.
Okay, then I got it wrong.
Only off by 1.
Only off by 1, but this is in Sagittarius, so this is this part. This is, we're looking towards the core of the galaxy, and the place is crazy with nebula and, clusters and things like that, because it's just a real...
And it's not too far away from Pluto right now, actually. And
like the Trifid is really close to Pluto, yeah.
It is, right. And it's about the size of a full moon. So you can actually take your binoculars, and if you know where you're looking, you can probably see a small fuzz where the Trifid is. And there's Thad.
Green Dr. Thad Szabo.
good evening.
Where are you? Are you outside?
I'm in my backyard. So I have telescope set up here. But still haven't worked out some of the camera issues and whatnot yet. So
you're not quite ready to go live.
Yeah. Are we okay? Well, we are on air right now.
We are on air. Yeah.
You know, if you give me
the core of the galaxy, you're going to see a lot, it's a lot denser in terms of stars, just because we're looking towards the center of the galaxy as opposed to, up or down or out away from the galaxy.
Yeah, and this is an area. This is less than a square degree, so I guess that's bigger than a full moon, but still a relatively small part of the sky.
Yeah, you could just fit, the full moon with a little room to spare on the top, bottom, left, right.
Mm-hmm.
Yeah. That's really cool. Well, that's great. That's our first Pluto viewing of the season, and I know Mike Phillips is going to be really frustrated because it's typically his job to bring us Pluto and Uranus and Neptune each. He did it last year, and we must have spent the whole virtual star party like, are we sure? Is that it? Is that it? Are we sure? And this, you're just like, yeah, there it is. There's Pluto. Let's move on. Okay, all right. That's this is how far we've come in a year. So. Perfect.
Ho hum.
Ho hum. There's Pluto. By the way, there's Pluto. Yeah. Live for you in a Google Plus Hangout on air.
Everybody step outside and wave to Pluto.
the Pluto's not. New Horizons isn't taking a picture this week. So, all right. Well, I'm going to move back over to Gary's view.
This is the Trifid Nebula.
Right on.
And, in color, it's nice because since I'm shooting in hydrogen alpha, I get all this hydrogen red area here. There's also a lot of blue, which is going to be some oxygen glowing, which I can't see. But I did take this.
Asked it where Pluto should be tonight, and the coordinates that it came up with actually match where it appeared in my image, so it must be Pluto.
In that you could see all those other stars in the field where the astronomy software was telling you.
Yeah, that's right, and my astronomy software has this capability to plate solve the image, meaning that I can take an image and it can match the stars up with the database that it has, and so I can sort of calibrate the coordinates of the image, and I can drive my cursor across the image and it will tell me exactly what celestial coordinates are right under my cursor, and when I moved my cursor to where Pluto was, sure enough, it appeared right there.
Well, what constellation is Pluto in right now? If people want to go outside and look up and try and find it.
It's in Sagittarius. I'm looking at it right now, and it's actually right. And the reason why there's so many stars around it, it's right on the Milky Way disk. So it's if you look towards Sagittarius, right towards the Milky Way disk, you'll be looking right at Pluto, even though you won't be knowing you'll be looking right at Pluto.
Yeah, I pulled back in the image, and yeah, it's embedded in a pretty dense star field.
Yeah.
Which made it a little bit of a challenge tracking it down, but.
Yeah, I think people, your telescope is quite a sort of narrow field of view, and so you're not looking at a very big chunk of the sky here. But I guess because we're looking into Sagittarius, this is towards these.
Yeah.
Totally out of luck.
Not so clear.
And Dr. Thad Szabo is trying to join us. He's having some problems with his internet connection, but we might get a view from his telescope as well. So we'll see if that all works. So just 2 telescopes tonight, but both astronomers have been instructed to go as quickly as humanly possible. And so hopefully, I think we're going to get through a ton of objects. We're just going to be efficient. This is going to be like a strike team. We're not messing around. There's not going to be any of this blah, blah, blah color commentary. We're just going to bang, just, hammer out all these objects. But before we as a treat at the very beginning, Lewis, you brought us something really special tonight.
I did. Well, I guess it's special. I have Pluto, which used to be a planet before being disrespected than just a planetoid or asteroid or some other kind of object. This is a 60-second long image. Pluto isn't very interesting to look at in a small telescope like mine. You can't resolve a disk or anything, but here it is, indicated by the 2 red marks on the display. Let me sort of zoom in the star field. Believe it or not, that's Pluto. You're just going to have to take my word for it.
Well, if you took another picture, it would have moved a tiny little bit, right?
Yeah, that's right. If we were to come back, probably in a couple of days, you should be able to see that move to a different spot.
So, Lewis, how do you know that's Pluto?
I went to my handy-dandy planetarium program, and...
All right, it should be live. All right, well, hi, everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is your virtual star party for Sunday, July 28th, 2013. In the middle of the summer, the long nights, the late start for the folks on the East Coast. I deeply apologize. Don't worry. When we move around to the winter time, we'll be starting at 5 o'clock our time, 8 o'clock your time. It'll be perfect. Prime time. While the rest of us won't even have eaten dinner yet. So it'll be good. So joining me tonight, we've got two astronomers, maybe a third, and we've got some other people along for color commentary. So joining me from Los Angeles, we've got Gary Ganella. Hey, Gary.
Oh, everybody.
And you got nice clear skies, Gary?
Yep, looking good.
Good. All right. And we've got Louis Mamekos from Central Pennsylvania. So he's over on the East Coast. So this is great. We're splitting the difference. We've got Gary on the West Coast. We've got Louis on the East Coast, and your skies are looking nice and clear as well.
Yeah. Good evening, Fraser. They sure are for a change.
Good. Yeah. It's been
many weeks.
Yeah. That's gotta be rough for you.
Mm-hmm.
And for color commentary is Stuart Foreman. And
Hi.
And Stuart, last week we were sort of set to go, and then Stuart was the only one who actually had clear skies last week, and so unfortunately this week the fog rolled in and